What could you do with $2.5 billion? We could probably feed millions of starving kids and families, or perhaps provide for homes for the poor veterans, maybe even give health care to those who need it. No, instead NASA has shot that money into space in the form of their new Mars rover, Curiosity, according to MSNBC. Packed with technology, this rover is being sent to Mars to explore the possibility of life and water. Suppose this rover does manage to make it to Mars and not come crashing down like Russia's. Suppose they do find previous signs of life. What do we do then? Is money going to come raining down because NASA has made a big discovery? Or are we going to have a repeat of the Apollo missions, where the costs outweigh the profits? For these reasons, the negative urges you to vote against further prioritization of Mars. The Oxford American Dictionary defines prioritize as to designate or treat something as more important than other things, which in this case is the exploration of Mars. That means that they're not listing it as one in the agenda, but actually prioritizes it as the #1 thing we should be achieving in NASA. Currently, the United States government already spends a lot of money on Mars exploration through NASA and private enterprises. The affirmative would need to argue for even further spending for another Mars mission, which brings us to our first contention, expenses. Many scientists romanticize the space exploration for the purpose of discovery. Some coin it the next frontier. However, many fail to acknowledge the motivations for exploring the new frontier. For practical purpose, pioneers moved west in hopes of mining and agriculture. Fame and glory alone will not fuel the drive for exploration. Plus, space exploration does not come cheap, as shown with the latest price tag on the Mars rover. Mars has proven resources of water, carbon, and silicate rock, but these can be found in even more abundance on the Moon and asteroids. Aside from miserable iron oxide, Mars displays no clear source of precious metals. Even if there were a little bit in the volcanoes, the cost of mining it would not be worth the profit. Unless there are clear outcomes besides purely scientific discovery, Americans won't buy it. As former President George Bush put it, there are vital differences between Lewis and Clark expedition and a Mars mission. Lewis and Clark were certain to discover places and things of immediate value to the nation. Plus, the cost of colonization, Dr. Sam Staken states, it will probably take decades of subsidy before a Mars colony could sustain itself. A 20-year program of $50 billion a year subsidies would hit $1 trillion. Who would want to pay to live on an arid, hazardous planet with no atmosphere? Our second contention is the amount of resources already put into the Mars space program. For the fiscal year 2012, NASA plans to appropriate almost $600 million specifically to Mars exploration. Furthermore, with the privatization of space, the United States is providing federal government funding, such as the latest Commercial Crew Development Program, which according to the New York Times will provide $269 million for the biggest space corporations like SpaceX on a Mars mission. Mars Science Laboratory, launched on November 26, is a rover that will assess whether Mars ever was, or is still today, an environment able to support microbial life. The expensive rover is the last push for discovering life on Mars, thus limiting the need for further exploration. Even though it was a risky mission, it proves that the federal government already acknowledged Mars exploration, but it needs not to be the top priority of space exploration. Finally, our third contention is the limits of current technology in space travel. The negative would argue that further exploration of Mars would be dangerous, especially if it is a manned mission, a likely goal. First, there are risks of radiation, which cannot be stopped by the thin aluminum shield previously installed on space shuttles. Professor Gino writes that there are two primary sources of radiations that astronauts can be exposed to. One is cosmic ray. The second is energetic particles emitted by the sun, particularly during solar flares. The effects of radiation are cumulative, so exposure becomes increasingly dangerous as the length of the stay increases. Therefore, the risks due to radiation increase arithmetically on long-duration flights. These problems need to be solved before long-term spaceflight can be achieved. Also, the surface conditions of Mars are very harmful to humans and not worth the expedition. According to Dr. Eric Drexler, Mars' surface atmosphere is over 99% vacuum. This means that explorers will need suits in pressurized holes like those needed in space. The atmosphere, being mostly carbon dioxide, remains unable to breathe even when compressed. Even if there are ores economically viable, as technology evolves, we will most likely send machines to mine it instead of humans. In conclusion, Mars exploration has reached its peak with rovers that will assess microbial life. Further missions could prove disastrous without adequate technology. The government has not given up on Mars, as seen with the funding, but there is a reason why Mars is not the priority. Public interest is dying, and there needs to be clear profits in order for private industries and NASA to design missions. Taxpayer money doesn't come from trees, so it is essential to have specific future plans in order for the taxpayer money to keep coming. NASA has already sent $2.5 billion to Mars. How much more do we need? Look at the big picture, vote negative.